has technology become a source of weakness? Are the benefits of using information communication technologies in military operation? There is the importance of network-centric warfare. In a potential failure, what should improve? What are the future technologies that might help mitigate this risk? So that's why Mario is here. I'm pretty sure that you will have also these answers. Yeah? Okay,
Maybe,
let's
hopefully.
see.
So, well, first of all, thank you for the introduction and good afternoon to all of you. Before going into the main part of my talk, let me make some opening remarks. Well, first of all, this work has been done with my colleague, Robert Koch, who unfortunately cannot be here today, but it's a co-work. Second thing, I'd like to draw your attention on top of the slide where my agenda is depicted. And I have been told to go a little bit faster through the first part of my slides because you're already somehow experts in network-centric warfare, to focus more on threats, upcoming advantages, and what we call robust network-centric warfare. Okay, so let me first of all start with an introduction, and again let me draw your attention on the picture which is on the right-hand side, a picture taken at the St. Peter's Basilica in Vatican. Both pictures have been taken more or less at the exact location. However, the difference is 8 years in time. And what you can see obviously is how ICT, information communication technology, changed our society. You see that on the lower picture, everybody more or less has a smartphone at hand. And this change of the society is also reflected in the military. The military is thinking about how they can use ICT in order to have more or better goals, or how to achieve their goals in a better way. And just like in any normal business, there's a strong interdependency between ICT on the one side and the goal of the organization on the other side. And for the military, the long-term ICT strategy, or one of the dominant ones, is network-centric warfare. And no academic work without a definition, though here is one of the definitions of network-centric warfare. I'm not going to read the definition. I'm just like to draw your attention on the picture on the left-hand side. Well, the idea is to connect devices in a better way, to make them able to share information, which should bring you to improved situational awareness. From our perspective, improved situational awareness does cover some events in the past and project something in the future, but does not cover the overall picture. That is the next level. It should bring us to what is called information superiority, to have more information and more relevant information to be able to make better decisions. And that is the next level, command superiority. That in turn should bring us to what is called effect superiority, to have better effects, and that in turn should help us to have a better results for the military. And one of the nations who have deployed network-centric warfare at a very high level are obviously the United States. Let me point out a military scenario. For those of you who are not part of the military, I try to pick out one typical example of the military. And let's start with the red guys over here. The red guys obviously do launch an attack against the blue side, which is the rest of the forces over here. And what you have on the military side is 3 different types of, let's say, units. The ones which I like to call sensors, the ones which keep track of the opponent, who do something like intelligence, surveillance, and reconnaissance. You don't have to read all of this, just figure out there are different types of units. And then, if they have track of the opponent, this information should be delivered to the one who needs to do the decision. This is be done by means of information communication technology. Military refers to this as C2, command and control, or command controlled communication, computers and intelligence. This means here, in contrast to civilian, it means ICT, and it also means delivering the information to the commander who is about to make the decision. And then, obviously, the decision needs to be enforced by the means of effectors. If you take a look at the MX or at the ship, which is displayed on bottom, units can fulfill multiple roles. They can either be sensors, part of the V2 grid, or even part of all the three means. So far, so good. So at the next slide, I'd like to draw your attention on what this implies in terms of information and communication technology. So what are the requirements for this? And here, before going into detail, the idea is what are CIS or ICT capabilities when it goes to an military operation, which is a large military operation, a so-called entry operation. So we're talking about a situation where all the units are moving. And we have a high intensity warfare, more or less. And again, you don't need to understand everything, but what you should take away from this slide is that there is a high dependency on wireless communication. Because obviously, if you are to run a military operation and your forces are moving, then you cannot rely on wired communication. And what you should also take away is that in the current situation, this implies a high dependency from the airborne layer or the space layer, which is over here. So in order to communicate with each other, you need to have the airborne layer and you need to rely on satellite communication, as we have already heard. Good. So far, so good. So let's take an interim conclusion. From our perspective, network-centric warfare relies on, well, first of all, interoperability. Your units need to be able to exchange data. Yeah, the software should be ready for network-centric warfare, which is the biggest showstopper right now. But that's not what I'm going to talk about because my talk is more or less future-oriented. But anyway, that's the biggest showstopper up to now. Currently, network-centric warfare more or less relies on line-of-sight communication, the communication from ground to the satellites and to other means. And especially satellites are very crucial when it goes to this kind of operation because it provides you access to the network, and it's more or less some of the only means to have access to. It provides you ability to keep track of the opponent, to have navigation skill and whatsoever. And one of the also should take away is that 64 kilobits was considered as too small. These are some of the lessons learned of the Operation Iraqi Freedom in 2003. And when it goes to A2AD, in particular, this can also imply actions to be taken in cyberspace. So what are some of the threats we see? What will the opponent do to stop NCW from working? Well, first of all is, having already pointed out, we have a strong dependency on satellite communication. So obviously what the opponent might do is to keep track of our satellites and stop our satellites from working. And as you can see on my slide, this is not an invention of the 21st century. Already beginning with the 1960s, nations were figuring out on how to stop satellites from working. Most of you are probably familiar with the James Bond movie GoldenEye, where the nuclear electromagnetic pulse was demonstrated, and this goes up through the latest demonstration of the Chinese that they are capable of removing a satellite from Earth, and it goes back to new technologies like laser systems, where we also try to stop satellites from working. And in addition, it's also about waste, which is flying through the air, which also may stop your satellites from working, one way or the other. One of the other threats I have not talked about so much right now is that, in contrast to former times where military was used to using specifically developed equipment, we are, except for a few occasions, not doing this anymore. Nowadays, military is using the same chips, like the one depicted over here, like any other company will do. And this in turn introduces the same vulnerabilities. The reasons, therefore, are that those chips are cheaper, they are available on the market, so that you can increase them faster into the military, and this in turn increase the performance. However, when it goes to manipulation, they are hardly controllable. So to detect a modification of the circuits is very, very difficult right now and requires an extensive environment to do so, which is one of the problems. And if you want to take a look on the right-hand side, you see one of those guys performing a modification on a Cisco router, for instance. Yeah, and these are also equipment used by the military, of course. Another threat is Another threat which we have chosen, there are a couple more, of course, is software-defined radio, which we think might be a future threat. So to make you familiar with software-defined radio, let me go more into detail what was before software-defined radio. It was hardware-defined radio. So in former times, the hardware defined the way in which we were communicating. So depending on the hardware, we had something like a high-frequency radio transmitter, the one you're used to from movies of the 50s. And depending on the hardware, we have something like smartphones and whatsoever. So the hardware, more or less, the chip design and whatsoever, defined the way in which we were communicating. Right now, this is all about to change. We have a new generation of radios, software-defined radio, in which the software defines whether this device is behaving like more or less like a mobile phone or an HF device. Simple analogy. The only thing you have to change is the antenna in the German version. It's a good thing for the military because obviously the military are in the need to adapt to specific environments. However, this is another piece where software is brought into our system and may introduce another vulnerability or a way of forming vulnerabilities. Okay, having said that so far, let's move on to upcoming advances. Let's go back to satellite communication. And before going through the slide, let's draw your attention on the bottom of the slide, on the picture. You can see that when it goes to satellite communication, different bands are available. Yeah? And what we used to using, not only the Germans, but the military in total, is the KU band. The KU band offers 5 megabits per second, roughly, and is used very often. However, when it goes to providing support for future missions, we have to say that the theoretical maximum capacity of what the KU band can deliver is nearly exhausted. And I have to say that both KU and K-band are used both in the military and civilian as well. So one of the advantages is that we as a military will try to look forward in how to use other bands as well. And one of the means of choice is the KA band. And the KA band promises 4 times higher data rates. And we're right now seeing an intensive growth after a first decline in the beginning of the century. And however, there are a couple of more downsides, and that's of course the reasons why this is not used yet. And one of them, the major one, is the high influence of weather effects. But what you should take away from the slide is that the current KU band is obviously something we will not see so much evolving in the future, but military is also looking on other bands to use. So there's a trend towards more diversity for satellite bands. And we have also upcoming advantages with regard to airborne communication nodes, especially if you're not from the United States. It's something European nations don't have so much right now. So the necessity of airborne communication nodes are going to increase. One of the reasons why we need airborne communication nodes is also something we've heard in the first talk. It's a latency. If you're going to send your signal from here to space and vice versa, it's obviously going to go through a long space. So once you go from ground to geospatial orbits and back, it's a high delay. And one of the advantages of airborne communication nodes, it's the ability to have a low delay. And in addition, airborne communication nodes can also be used to deploy additional equipment over here, like network, Centric, enterprise information server, and whatsoever. Yeah. And to go back to my introduction, network-centric warfare is not only to make anybody or every unit communicate with each other, it's also about performing some kind of filtering. So the commander needs the relevant information and not all information. And this is something that can also be done here. And I'd like to draw your attention on the HF links. Currently, you may have seen on my picture, HF links are not used so much in the military. One of the reasons, therefore, is right now the bandwidth is limited to 9,600 bits per second, which was obviously too low. Yeah, if you compare the demands of the Operation Iraqi Freedom. However, there is there is an increase in speed, which we will have in the future. New waveform, that goes back to software-defined radio, and new standards are allowing transfer rates of up to 240 kilobits per second, which should be sufficient to have something like real-time video over HF channels or IP networking. So here, this sounds very promising for the future and will be seen more in the future. And the other thing is laser-based communication is also one of the upcoming advantages. Last year, the National Air and Space Aeronautics of the United States successfully demonstrated the capability to send a signal from Earth to Moon and back at a very, very high speed. 622 megabits per second is very impressive. And if you reduce the distance, it's supposed to go something like 10 gigabits per second, which is very, very fast for the military. And in addition, one of the advantages is also that it's hardly detectable for us. It's invisible to the humans, and it's only detectable within a few meters. And in this, in turn, makes it very difficult to interfere by the enemies. And in addition, the use of quantum cryptography allows very, very fast, reliable securing of those communications. Well, this is something in the near and not too distant future we will going to have. So taking all these threats and upcoming advantages into consideration, I'd like to give you an insight on what we call robust network-centric warfare, on something we see in the future. Let me start with the lowest level of the ISO-OC reference model and then go up all the way to layer 7. So on the layer 1, we will have a more diversity of different technologies in order to reduce our dependence on satellite communication. And even within the satellite communication, we will have a mixture of different bands because of the arguments I outlined, because the theoretical maximum capacity has already been somehow reached. We will see at layer 1 in the near foreseeable future an introduction of laser-based systems, which will strongly enhance our capability to transfer data very, very fast. And we will see HF communication coming back to the military because of the high bandwidth it offers. Nevertheless, we will also see airborne communication nodes because of their, first of all, of their bandwidth and their redundancy, and because it's of their high flexibility. Yeah? Nevertheless, they have limited dual time in comparison to satellites. Yes, when it goes to satellites, first of all, hardening is something that you should take into consideration. And for the future, we talk about passive or active self-defense. So a passive here in this case means just to keep track of your surroundings and to be able to do something like automated collision detection and avoidance. This is something we will see in the near foreseeable future. And some nations are thinking about employing active self-defense capabilities at satellites. So for instance, to have the ability to use lasers over there to stop rockets from entering. And some of them, but I agree to your point, which you have said, some nations are thinking about making satellites more smaller and more dispersed. We'll have to see how this will evolve in the future, but some nations, for instance, think about having one satellite who does the defense part and other satellites who do the regular communication. That's one of the ideas on which this is going. Going up to layer 2 and to 4 of the ISO-OC reference model, what we see is the need to be able to adapt to a changing link capabilities and connection types. So our protocols need to be aware of whether we're using a satellite communication or whether we are using whatever, an airborne communication or even a wired communication. So we need to be able to split data through multiple transmission paths, to use different, or to cope with different delays. And we need to be able to adapt, of course, error correction, but in a better way. I'm going to talk about this a little bit more on the next slide. So when it goes to layer 6 and 7, what we need to do is, and let me start here with advanced quality of service and what I think is, or what we do think is advanced quality of service. Normally, quality of service is something like you, depending on the service, you categorize your traffic into different classes. So normally you say video and audio is something like you need to do in real time, And whatever email, for instance, is something you can delay with a certain time. But that's, from our perspective, not so much true for the military. It can happen the fact that, in our case, video is less important than email, for instance, because it may happen that our management information system is using email, so it needs to be transferred fast, and that video in this specific case might be unimportant because our satellite is observing something which is not relevant for the current situation. So the quality of service needs to be adaptable or advanced in this case, that it depends on the military objective, whether the traffic is highly relevant or non-relevant, and not on the type of service itself. Of course, we need to scoop out redundant connection links, so it's got to be able to use redundancy in a good way, because some of the traditional routing protocols, they just get rid of redundancy. If you take a look at, for instance, spanning tree, they will just disable redundancy, which is not something we want to have here. And of course, we need to look for ways and means to reduce the amount of data transferred. And one of the things that sounds very promising within the forces is the use of vectorized data, especially when it goes to pictures about locations on the map. And of course, from an opponent's perspective, you try to get rid of those network-centric warfare elements. So this in turn means for you, for the blue guys, to be able to counter those kind of attacks. So therefore you need computer network defense capabilities to be able to react in real time. And this in turn means organization, financial aspect, but also the human aspect as well. And last slide. From our opinion, our system, especially when it goes to airborne, are in the need to be able to act autonomously for a short period of time. So we should be able to compensate a loss of communication, at least over a limited time window, and that should not be limited to safe operation mode. So we're talking about what has already been said, semi-autonomous weapon system. In addition to this dependence on network-centric warfare, we should nevertheless be trained to cope with a situation where a highly technological opponent might take away all of the advantages. So we should be able to operate without any communication. We should have a plan what happens if GPS is not available. Yeah, either because the opponent takes it away or because we need it in case of covert operations. And last statement, for us, the authors, this does not imply lethal autonomic robotics. So it's not about having a computer doing something like a kill operation. That's not what we are talking about. Okay, we talk about semi-autonomous weapon system. Have the human in the loop, especially when it goes to kill people or hurt people. Okay?
You're on time.
Thank you.
I cannot believe it. Okay, thank you, Mario. I don't know if the audience has questions on what Mario told us. Well, yeah, please.
Stavros from the Greek MFA. I couldn't help noticing that there has been some superposition regarding distances and latencies and speeds and maybe ranges. You said that it's preferable to have airborne means of communication because the latency would be higher when dealing with satellites. But then you showed us a slide with a beam sent behind the moon. So there goes a big latency. And of course, then when you have an airborne means of communication, this means that you're very limited in range. You cannot go far sideways. And well, it hasn't been too clear to me, who I'm not military, how can a means be preferred to another in over battleground? What do you want? You want range, you want latency, you want speed, you want...
To give you an answer, it depends on the situation, of course, whether I want to have speed or whether I need to have redundancy and whatsoever. So it depends on a lot of aspects. And to come back to your initial question, the good thing is with regard to airborne communication, it's something you can already buy on the market. When it goes to laser-based communication, for instance, first of all, well, we don't know about when this is really deployable in practice. So airborne communication is something we will see. If you take into consideration a time frame, you will have it quite fast because it's already available. When it goes to laser-based system, we don't know when this is going to be really deployable within the forces. Okay?
So it's according to the mission and the geopolicy of your state. I
Yes.
mean, if you're United States, of course, you're global. So you need all of that the best way.
As
Yes.
always, it depends. It depends on a lot of aspects and level of ambition, what kind of nation you're and whatsoever.
Okay. Somebody else? Well, now it's a hard. Yeah, you're on time. I have to say that.
2 seconds.
But you know, this is zero when Steve is on your back. You know. Okay, Steve, it's.
Thank you, Nico. For Mario, I have a question, but there's 5 different parts. Part A, B, C, D.
Oh,
No. Just addressing the latency issue for 1 second. Let me give you a classic example, and I'll move from there. If I were Mario discussed UAVs. So if the next generation UAV will have a lot of, with the FPGA boards, edge analytics is possible. So whether that we can retask something. So for example, if I have a UAV that's looking for metallic load, detect for IEDs, and I see a sniper on the roof, that's something that latency matters. But the second part of the question is, as part of the Department of Defense High Performance Computing Modernization Reform Act, we also want to see how's that data being processed, which is also a piece of it. So we have to push compute to the data, which also impacts latency. So I think that's a more extensive conversation than just the slides that Mario showed is one piece of it. But for Mario, my first question would be, next generation UAVs and satellites are indeed moving to Ka band for higher data throughput.
Yeah.
So in some areas for future conflict, whether it's Africa or whether it's the Asia Pacific, a lot of those areas are in tropical regions with high precipitation and downlink dissipation for Ka bands up to 400 times. Talk to us in terms of resiliency, what your thoughts are in terms of that lower latency capability to best support the warfighter versus that Ka band resiliency aspect.
I'm not sure whether I got your question right. Sure. So, of course, weather effects do influence the Ku band, that's for sure. And to be honest, it all depends on your, on your level of ambition. Where do you see in the near foreseeable future that your forces are going to be deployed? And referring back to my scenario, at least from my personal opinion, I cannot see any high intensity mission in those kinds of the world right now. But
I would say streaming video chews up a lot of data, and Ka band seems to be a very cost-effective way for satellites and UAVs. But so it's more of a Ka band question for you. But true, Ku band is in use, C began, etc. But Ka band is just one of those things from a resiliency perspective. Just your academic thoughts on what you think the resiliency factor of Ka band is.
Again, I'm not sure whether I really got your question right, but from what I wanted to point out is that if you go back to satellite communication, then you obviously also have to have a mixture of different bands, of different satellites, and even it depends whether you're willing to buy satellite bandwidth on the free market or whether you want to deploy it on your own. I'm not sure whether this really addressed your question.
Good enough. I'll move on to part B. How about that?
Okay.
All right, part B. There's the commercial microsatellite market is pretty robust in terms of microsatellites, but that's commercial spec. And then we have a lot of larger satellites, which is more mil spec. In terms of supply chain for the constituent components, counterfeit chips, etc. What do you think the risk is in terms of commercial versus mil spec?
Do you mean the reason to use it in the procurement?
If you had to, with limited budget, based on the big bets of outsourcing or internal development, where would you go?
Again, depends what am I? Am I a big nation? Am I the United States? Or am I Estonia? So whether am I Estonia, you figure it out. It costs a lot of money actually to do so. So whether I'm a small country, I would definitely not in the first hand think about buying my own military satellite. But when you go back to big nations, it's something you have to have in the arena, because obviously when military wants to make a mission in a foreign country, military is not the only one looking for bandwidth at that specific moment. Other players are also looking for the market. So the prices to have access to civilian bandwidth will increase, and that's a problem. And to be honest, if you go back to military, you have high bandwidth requirements if you want to deploy many people, many soldiers.
Saved by the bell. Saved by the bell. Okay, Mario. Thank you for your presentation. This is just to remind you being here.